make it easy, first we have to make the known of this question, and I already make it here. The pressure 1 means the pressure at the beginning of the trip, which is 2.81 times 10 to the power of 5 Pascal. T1, or temperature at the beginning of the trip, which is 27 degrees Celsius. P2, or pressure at the end of the trip, which is 3.01 times 10 to the power of 5 Pascal. Don't forget, the question said that we have to ignore the expansion of the car tire, which means volume at the tire volume at the beginning of the trip is equal to the tire volume at the end of the trip. So we have to make it. So we can use the formula of Boyle-Gay-Lussac equation here. And because the volume 1 is equal to the volume 2, we can just remove it. Okay, now we can just substitute this known to the equation. Oh, don't forget to change the temperature first. Because it is still Celsius, we have to make it into Kelvin by 27 plus 273 equal to 300 Kelvin. Okay, now just substitute the known into the formula. 2.81 times... Okay. You can times it. Okay, 3000 times 3.01 times 10 to the power of 5 is... Oh, the answer will be 30. 3021.35 Kelvin. This question is about heat. I will read it again for you. A copper bar with the mass 0.5 kilograms is heated at 200 degrees Celsius and placed on a large block of ice. What is the mass of the melted ice? So if ice was placed under a hot copper bar, it will melt it, right? Okay, so to know the mass of the melted ice, we use Assigment black. The question didn't mention the specific heat capacity of copper and ice. It means we have to know it first. So I have write it here. Specific capacity of copper is 387 joule per kilogram Celsius, and the delta temperature is 200 degrees Celsius, or 200 degrees Celsius minus 0 Celsius means 200 degrees Celsius, right? And the mass of the copper is 0.5 kilogram, and the heat of the fusion of the ice is 336 times 10 to the power of 3 joule per kilogram. It's to make it more easy. Okay, and what is the question? What is the mass of the melted ice? Don't forget what I said before, we use Assigment black. Key absorb is key of the copper because the copper is absorbing the color, the heat, absorbing the heat, and key receive is from the ice. Okay. Because the common formula of key or of heat is mass times specific heat capacity times delta temperature is equal to mass times L, or heat of fusion of the ice. So just substitute the value here into the formula, like I did. Mass of the copper, specific capacity of the copper, and the delta temperature here equal to mass. That's what we want to look for, right? And the heat of fusion of the ice. Okay, after multiple all of this, we move this into the side, and the result will be 0.1 kilogram. This is joule and this is joule per kilogram. Mass. So the mass of the ice is 0.1 kilogram.